Okay, guys. So I see that you have done with the test on the numbers one as two as well, but nobody was able to solve more than 4 questions in numbers two. Was it that tough?
Yes, Kesari.
Yes, Kesari.
I think we need a full revision of numbers two once again,
Sure,
especially
sure. We'll
that,
have one. We'll have one. Don't worry that. I
especially
have.
that remainders kind of things.
Yeah, we will. I mean, I was waiting for this numbers two and one and two part done. That's the reason. Like, that's why I said it before as well. Once you get it done with numbers one and two, then I will give you the worksheet on numbers three. Otherwise, what will happen is you will try to go revise numbers three and then you will completely forget numbers one and two. Numbers one, numbers two, numbers three are like three different chapters altogether in numbers. It's that vast. So it happens here. Don't need to worry that. We'll have one revision session. In fact, if you need, we'll have 2 sessions. That's not an issue. In fact, we'll also have revision sessions when our syllabus gets done. So that's like we'll have a topic, let's say like we are having on quadratic equations. So let's say there's revision on quadratic equations. So what we'll have is I will give you some questions, then there will be some doubts from your homework sessions, some doubts that you might have solved in your test papers or various things. So we'll have total complete discussion part so that each of your concepts gets clear. Okay, so today we'll have the important topic of algebra, that is quadratic equations, and you might have almost everyone has done it in their ninth standard at least once. I suppose. Anybody who is not aware of what is quadratic equations? Okay. Yeah, Attam. Okay. So when you are completely aware, can you let me know what is quadratic equations?
A equation in which the highest power is 2.
Okay, and what is a power? What is known as power of the equation then?
Degree.
You are just stating the synonym. Okay, so if this is this a quadratic equation?
Power of a variable.
And what is the variable here?
X, here the variable is x.
Why not k?
Oh, the function, because in function we have given it as x, so x is the variable.
Okay, so is it now a quadratic equation?
Yes.
Anybody, any doubt with what we currently just discussed in the last 30 seconds? Why it was not a quadratic equation earlier? Why is it now a quadratic equation? Okay. So with that part done, let's move to what are the roots. So what are the roots of a quadratic equation, guys?
The possible values for an equation to satisfy.
For an equation to satisfy what?
I mean, if how do I say this? Now let's take if kx plus k square plus 2 is equal to some 5.
Mm-hmm.
So now which values of k will satisfy so that the equation when solved will give a result 5.
Will give a result
No,
5.
I
will
mean the
give
end
result
result.
0
Yeah, 0.
Why 0? Why only 0? Why
because
not
it's the
any?
root.
So, but why 0? Why not any other number? I got your point, it's a root, but why is it considered at 0 only? Why not at any other number?
Because the value of the function at that root is 0.
Okay, so is it, you mean to say, is it defined like that?
I don't know.
Anybody? Yeah, guys, anybody? If you need time, I will give you 30 seconds to think. Anyone with the solution as to what is the root now, or why at 0? Okay, let me explain. So we again come back to a normal geometry part and coordinate geometry part. Like I said, algebra is closely linked to that, so we'll move that way. So let's say this is your parabola, or yeah, basically just to heads up guys, any quadratic equation, like any normal equation, ax plus by plus c gives you a straight line, this gives a parabola. So whenever this touches the y-axis, so like I said, this is equal to y. So what do we want is actually when does the parabola cuts the x-axis, and these are called roots. When will these be uh, when we'll find the value of this x-intercept, basically when y is equal to 0, and that is why we equate this is equal to 0 and call these two as roots. These are roots and this is the y-intercept. So now is it clear why do we use it only for equal to 0 as only, and why not 5 or any other value? Anybody any doubt? Okay, then let's move forward. So with that part done in the quadratic equations, now we know what are roots. We will see how to find roots. So anybody knows how to find the roots?
Formula.
Which formula?
Quadratic formula.
Yeah, tell me.
Minus b plus minus
Minus b plus minus.
under root b square minus 4ac
Okay.
upon 2a.
Are you sure it's 2a?
Yes.
Okay. So I will get one root from this.
Both roots will be there because plus
Okay.
minus sign is used.
Acha. Okay. Okay. Sure. All right. Two roots then. And what is this part known as?
Discriminant.
Okay. And what if uh, b square is less than 4ac?
Imaginary roots.
No.
So if I have imaginary roots, what will be its geometrical interpretation? Will the parabola also become imaginary?
Sorry, no, I.
Okay. Anybody else? My question is, if the roots become imaginary, what will happen of that parabola? I mean, the origin of roots is when the parabola intersects the x-axis. Those are the roots. If the roots are imaginary, will the parabola also become imaginary? If you think the parabola will become imaginary, type A. If you think it will not become imaginary, it will still be real, type B. Easy way. Imaginary, real. What do you think so? Type in the chat box. Let's see. Let's hear a response from everyone. Okay, I've received one response. I won't say if it is right or wrong currently. Let's first hear from everyone. Okay. Now I have started receiving both the responses. Others, I've received just 3 responses. From 7 people, 3 responses, 4 still remaining.
Kesri, can you repeat the question? I didn't understand it actually.
If the roots are imaginary, like b square is less than 4ac, what will become of the hyperbola? Will it still remain real, or will the hyperbola also become imaginary? If you think the hyperbola is imaginary, type A. If you think the hyperbola will remain real, type B. Okay, 4 responses, 3 responses still left. Anshula, your response is remaining.
I really don't know about this.
Whatever you think, it's not a exam you are giving.
Okay.
Priya, your response is remaining. Uttam, your response is remaining. Priya, your response is remaining. I'm waiting for it. I'll need complete contribution from my class now. Priya, are you there? Am I audible? Well, Priya is currently reaping the benefits of an online class. You cannot know who is present, who is not, or there are some technical issues as well, maybe.
I guess her mic is not working.
Okay, but there's the chat box. That's why I said the chat box. There's no response on the chat box as well. Okay, let's move forward then. Guys, like I had said before, if this is what is your axis would be, so what will happen is, let's say this is your parabola. Now When it was your normal thing, this was like this. It intersected at 2 points. But when there are no roots, how can you get a situation like that? It will only be possible when it will be like this. Now you can clearly see this parabola is not intersecting x-axis anywhere, and it is still real parabola. It exists. So this will be the correct answer. It cannot be imaginary. The parabola will be real and still have no roots. This is the geometric interpretation of what happens when the roots are imaginary. Now is it clear for everyone?
Yes, Kesari.
Okay. There's one more method that you guys used to do, and that is the normal factorization method, right? Of any ax squared plus bx plus c is equal to 0. So you split the middle term, found out the common factors, used two brackets and equated them to 0, and you calculated the roots. Also, there's one extra method that you guys might have done, which is not that efficient, but for you guys might have been taught it for the sake of knowing it, and that was completing the square method. So these are three methods how we can find the roots of the square. Now coming to the next part, and that would be how we can also calculate apart from knowing the roots. What if I make slight changes in the roots? Now, okay, if the roots are alpha and beta, let's say the roots are alpha and beta. So the equation will be ax squared plus bx plus c. My simple question is, if the roots become 1 by alpha and 1 by beta, what would become of the equation? Anybody? Okay. Let me tell you one more thing that might help you slightly. That is a simple concept known as theory of equations. So here, currently, if alpha and beta are the roots of the equation, alpha plus beta is known as minus b by a, sum of the roots. And product of the roots alpha into beta is known as c by a. This c by this a will give you the value of product of roots. Now what if I try to construct a quadratic equation using the roots as 1 by alpha and 1 by beta? What will be my new quadratic equation? Can you use this theory to calculate it? I'm giving you 2 minutes. Try calculating it. If you guys want me to repeat the question once again, do let me know. Otherwise, I'm giving you 2 minutes. Think. Angela, I don't want the roots. I want the quadratic equation. Yes, Manideep, correct? Others, if you're facing any problem, any doubts, ask me. One more minute. Yes, Janvi, correct answer. Guys, are you stuck? I haven't received any more answers, just two correct answers. 30 more seconds. No, Anshula, that's not the correct answer, I'm afraid. Okay, time's up and I still receive, yeah, now Anshula, now your answer is correct. So just three answers. Let me tell. So the final answer would be, guys, cx squared plus bx plus a. To those who haven't got the answer yet, where did you guys get stuck? See, it's not that tough. Let me show you. Let the roots be x1 and x2. So x1 plus x2 is what? 1 by alpha plus 1 by beta is alpha beta plus beta. Take the LCM of denominator. Now what is the value of alpha beta? C by a. Alpha plus beta is minus b by a. So sum of roots is minus c by b. Similarly, the product of roots will be, sorry, 1 by beta is equal to a by c, because this is quite opposite of this. Now what is left is your simple part. Just put it in this form and you will get cx square plus bx plus a.
Casey, that is minus b by c, right?
Oh yeah, sorry, my bad. So finally you will get the equation when you arrange it, cx square plus bx plus a. Everybody clear, guys? Anybody any doubt? Please ask me right now itself. Guys, anybody any doubt? Please type in the chat box if it's clear. Others, I've received 3 responses. Anybody who has any doubt, please ask me right now itself, because we'll be dealing with the changing of these roots quite a lot. And like the major chunk of quadratic equations ka question will be based on roots. So this is a very important technique. So if you don't understand it now, you will face some issues going forward. So if it's not clear, please ask me right now itself. Okay, then I assume it's clear. Okay, then let's move with the next part, and that would be the nature of roots. We have covered the sum and product of the roots. Constructing quadratic equations, now you know how they are to be constructed. And so just a general formula, if just stating the reverse of what I had stated before. If this is your quadratic equation, then how will it look with the roots part? Sorry, plus alpha beta. This is how it will look. Equal to 0, obviously. So product of roots and sum of roots with minus sign. Don't forget this minus sign, guys. A lot of mistakes are made because of this part. Okay, now with that part done, you might have questions in various formats, like I said, construct a quadratic equation where one root is k times the another. So how will it look? Let's say one root is not this pen. One root is alpha. So what will be the other root? K alpha. So what you will have, the equation is x square minus k plus 1 alpha into x. Like I said, sum of roots with negative sign, and product would be k alpha square. Now, what if the roots are reciprocal of each other? What will be the product of the roots, guys?
C by A. Sorry, A by C.
Okay. Construct a quadratic equation with these as the roots. Answers in the chat box. Yes, Rasvik and Johnny, correct? Correct, Manideep? Others? Hurry up. This is the basic question. Shouldn't take more than 1 minute at max. Yes, correct, Anshula. Others? Prerit, your answer? Uttam, your answer? Okay, Uttam has left. Yes. Prerit, am I audible to you? Okay. I guess there's a connection issue from his side as well. All right. So next, calculate same again, but the roots are now this, and I want the answer in 10 seconds. Yes, correct answer, Manideep. Correct, Aswik. Others? Yes, Janvi, correct answer. Are other facing a technical issue, or is it not visible or something? I have received the same set of 4 answers which I received for the previous question. Prerit, are you there in the session? Okay. I guess let's move forward then. So guys, now you have learned how to construct a quadratic equation from given the roots. What we'll have is we'll go to the further level, and that would be a factor theorem. Now from factor theorem, it's like quite similar to numbers but slightly different. Let's say you have your f of x, and let's say it's x square plus kx plus p in any number. Now if the value of x, I put alpha, and if after putting alpha instead of x in this equation, I get the value 0, then I'll have to say alpha is the root of the equation, and I can also say this equation is completely divisible by x minus alpha. Please note it, guys, it's very important, and this is known as factor theorem. I repeat it once again. If for any f of x where x square plus kx plus p is equal to 0, if we replace x by alpha, alpha would be any number, any value. If it comes out to be 0, the final value, then alpha will be known as root of the equation, and x minus alpha will always be able to divide this polynomial completely, no remainders. So let's put a test then. So let's say now if I give you the equation 3x square plus 9x plus 15, find the remainder when it is divided by 3x plus 1. Guys, am I audible to you?
Yes, Kesari.
Okay, I got disconnected for a second there. Yeah, so everybody clear with the question? This is your polynomial. You have to find the remainder when it is divided by this without using the long division. You will have to use the factor theorem. Take 2 minutes. Yes, Chanchula, correct? No, Janvi, please recheck your calculations. Yes, Manideep, correct? Others, hurry up. Quite an easy question. Ashwik, Prerit, haven't got your answers yet. Ashwik, am I audible?
Yes, yes. I'm not able to figure out how to use this.
Okay. Okay. Others, those who have given me answers, fine. Those who haven't yet, am I audible to you guys? Guys, first just Type a yes in the chat box, so I would so that would let me know who am I audible to at least. Please type in a yes if I am audible to you guys. Okay, apparently I'm audible to just Janvi. Others, am I not audible? Okay. So Janvi, Anshula, Ashvik. Apart from this, am I audible to anybody else as well? Manideep, am I audible to you?
Yes, Kesari, it's fine.
Okay. All right. So I guess we have total 7 participants, including me. So I should receive at least 6 yes. I don't think I'm audible to Prerit and Priya. They have some connection issues, maybe. Okay. So, Ashvik, see, the important thing is from here, calculate x is equal to minus 1 by 3, like I had said. Substitute it here, x ka value, and you will get answer as 37 by 3. Like I had said before, if x minus alpha divides it completely, then alpha will be the root. So what is this? X minus 1 by 3 is equal to 0, basically. So that would be 3x plus 1 is equal to 0. So if I put this, then I will get the value this.
I got this answer, but I thought this might not be the remainder.
Okay, all right, fine then. Okay, all right then. Let's take one more question. And what if this was 3x plus 1? So we had this one. Now, what change should I do so that I can make it completely divisible by 3x plus 1 then? What change?
Subtract by 37 by 3, I think.
Yes, perfectly. I should subtract by 37 by 3. Okay, so with that small part, let's move to the next part, and that is if I give you, let's say f of x is a quadratic equation, and if in that quadratic equation, if I put x is equal to 0, I get 14. All right, the value would be 14 if I put x is equal to 0. Like I had put here x is equal to minus 1 by 3, I had got this part. Similarly, instead of in that quadratic equation, if I put x is equal to 0, I will get 14. Now, the remainder of f of x when it is divided by x plus 1 is 25, and when divided by x minus 2, the remainder is 10. These are the remainders when divided by this and this. I need you guys to find me what is f of x. For simplicity, start with f of x is equal to ax squared plus bx plus c. When you start using these three criterias, 1, 2, 3, you have three unknowns a, b, and c. You have three equations. You can solve it and get your answer using this. I will give you 3 minutes. It can be slightly tricky, so take 3 minutes and solve. No, Aswik. Unfortunately, that's not the answer. Please check again. No, Prerit. That's not unfortunately right as well. Also, were you not able to find the value of B? Your middle part is coming out to be minus 2B. Please recheck. Correct answer, Anshula. No, Prerit. It's still not correct. One more minute, guys. No, Janvi. Okay, so it's time up, guys. Let me pick it up. So this was the question. Now, as per the question, let the equation be ax squared plus bx plus c. Now, if I put x is equal to 0, so according to this one, my value comes out to be 14. So if I put here 0 plus 0 plus c is equal to 14, that means my c is 14. So this is sorted out. Now, if I put x is minus 1, it comes out to be 25. So a into 1, because minus 1 ka square is 1, minus b plus 14, because I already know the value of c is 25. If I let it go there, a minus b is equal to 11. I get one equation in a and b. I need to get one more, and I have one more information. If I put x is equal to 2, I will get the value 10. So if I put x is 2 here, I'll get 4a plus 2b plus 14 is equal to 10. Clearly 4a plus 2b is equal to minus 4. Now if I solve this and this, I'll get a is equal to 3 and b is equal to minus 8. No, Ashwik, it's still not correct. Ashwik, were you listening? The approach?
Yeah, I was following the same approach. I missed out some calculation in between. Same approach I've been approaching.
Okay, I trust you then. So my final equation would be 3x square minus 8x plus 14 is equal to 0. Unfortunately, I got just two correct answers, Prerit and Anshula's. So guys, for everybody, is it clear what was the steps? And Ashik, how are you getting the last term as 28? I mean, the last term is the basic and pretty easiest part. How are you getting that as 28?
No, I got the values of A as 9 by 2 and B as minus 13 by 2. So that's how I ended up with 28 there. Maybe
Okay.
I did something wrong in between calculation.
Okay. So is this part clear, everybody? Any doubt? Those who added got the answer. Janvi, is it clear?
Yes, Kesari, it's clear.
Manideep, okay, Manideep says it's clear. All right. Others have given me the answer then. Okay, great. Let me give you one more such sum. So, with just a slight twist, and that would be, now let me take it to a new level. Instead of quadratic, let me go a level higher. So, what if I give you a cubic equation? The theory that you have to use is the same, exact same. The remainder theorem is exact same, the factor theorem. If f of x is divided by x square minus 4, here this f of x is completely divisible by x square minus 4. Completely divisible, that means it does not leave any remainder. I need you guys to find me the value of a plus b. What you guys have to do? That's your call. I want the value of a plus b. Use the remainder theorem that was said. Yet again, this is a tricky question. I'm giving you, no, this time 2 minutes, not 3 minutes. It's not that tricky. Calculation part is quite less. The trick is more, but the calculation is less. 2 minutes. Let's see who gets it first. Yes, Aspik, you are correct. Anshula, please check your sign. Manidip, correct. Now it's correct. Thirty more seconds, guys. No, Prerit, that's not the answer. You are way on the wrong track, I guess. You have done something different. Prerit, was I audible in the previous part of the session?
Actually, I went to take my dinner.
Okay. I guess that's where you missed some critical parts. Okay, guys. So using the remainder theorem, you will have to use x is plus 2 and x minus 2. So once you can put 2, once you can put minus 2, you will get a is your normal value, and that would be, what was that? It was 1, I guess. Yes, it was 1. And b would be minus 12. So when you add it, you'll have minus 11.
Actually,
Is it clear, guys?
I did the same thing.
Then you did some
No,
calculation error.
actually my method was correct, but I took as plus 4 and minus 4x.
How come it's plus 4 and minus 4?
That's what I got it wrong.
Okay. Now, what if we extend it? We had seen a cubic. What if we extend it to a much more higher degree? Now, find the remainder when x raised to 888 when divided by x square minus 5x plus 6. What is the remainder? Now let me know. Guys, just a quick hint. If the quotient is this, will the remainder have higher degree or same degree or lesser degree than this quotient? The degree of the quotient would be higher, same, or lesser. Among these three options, what would be the correct one?
Kesari, is that one a divisor or quotient?
This is sorry, my bad. This is the quotient. Once again, divisor. This is the divisor. What will be the remainder? My bad, I jumbled up with my words. So what will be the degree of the remainder? Will it be higher? Will it be equal, or will it be lesser? Okay, let me say then. Degree of quotient, I'm telling a quotient, yes, again. Something's wrong with me today. Degree of your divisor will be always greater than degree of your remainder, always. So if the degree of your divisor is 2, degree of your remainder would be either 0 or 1. It cannot be 2. So this is the hint. Now solve the question. No, Prerit, that's not 0. You mean to say the remainder would be 0? That's not the answer, unfortunately. I'm waiting for the answer, guys. Guys, is it clear how you have to solve the question? Or I feel there's something missing that you guys are not understanding. It might look tricky, but it's not that tough question. Take one more minute, then I'll take this question up. No answer yet. Okay, let me take it up then. Let me assume that x raised to, okay, this won't work. Yeah, x raised to 888 is equal to f of x, that is my quotient, into x square minus 5x plus 6, that is my divisor, plus ax plus b, that is my remainder. Now, can I split this into x minus 2 and x minus 3? Is this much
Yes.
part clear, everyone? Anybody any doubts till now as to how did I get this or this? Okay. Now, if I put x is equal to 2 or x is equal to 3 here, this will become 0, right? This will become 0.
Yes.
And what I will be left here is, if I put x is 2, this is 2 raised to 888 is equal to 2x plus b.
Yes.
Also, if I
3.
put x is equal to 3, this will be 3 raised to 888 is equal to,
3x plus b.
yes, quite correct. Now, if I subtract this,
X.
this will be my,
X.
yes, or will it?
Should be 2a plus b also.
Yes, 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 I was waiting for it. I was waiting for it. I'm writing something and everybody's telling yes. It will be 2a plus b and it will be 3a plus b. Quite correct. Now if I subtract, this will be 3 raised to 888 minus 2 raised to 888. This will be the value of a. If I put the value of a here, I'll get something as b. And this is what your remainder would be. Main important part is not this calculation, it's understanding this part. This part. Is this part clear to everyone? Guys? Is this part clear, everybody? Everyone?
Yes, Casey.
Okay, perfect. We'll take one final question for the day, that is how you can be asked quadratic equations in some different way as well. This is slightly a standard question, but still. Let's say you are given the question 4 raised to 2x plus 1 plus 4 raised to x plus 1 is equal to 80. Now this is not your normal quadratic equation. This will be converted into quadratic equation. And you guys need to tell me the value of x. Anybody any ideas?
Should we use logarithms for this?
Whatever you want to use, you can. But I won't
Sorry,
be
can you
giving
repeat
you.
the question, Casey?
Yeah. So this is the question. 4 raised to 2x plus 1 plus 4 raised to x plus 1 is equal to 80. Find the value of x. There are some concept of indices. I know I haven't discussed it, but if you guys remember it from your school days, then yeah.
We need to tell x value, right?
Yes, the value of x. Yes, that's correct. Ashwin, did you guess it or did you solve it?
I mean, I didn't solve it, but substituting x value, that's it.
Okay, so you guessed it.
Yep.
Well, guys, there are two methods. Let me show it to you. Otherwise, it might unnecessarily trouble your brain. So, see, uh, 4 is to 2x into 4. I take this plus 1 outside. Plus 4 is to x into 4 itself and 80. I cancel this, I cancel this, I cancel this. Now if I assume 4 is to x is equal to y. Okay. So what will this become? Y square plus y is equal to 20.
Yes.
Is this part clear to everyone?
Yes, yes.
Everyone? Ashrik, Janvi, Manideep, Prerit, everyone?
Yes,
Yes,
Yes.
yes,
yes.
yes.
Okay, great. Now this is your normal quadratic equation. Once you solve it, you
X
will
is
get the
equal to 1.
option -5 or 5. Now if your this cannot be this because 4 is to x, anything raised to something here won't be negative, so it has to be 4, so x will be your 1. So when you even substitute it here, you will have 64 plus 16 is equal to 80. So this is how indirectly quadratic equations might be asked to you guys. So yeah, this is basically what is the basic concept of quadratic equations. The two important ones which I would say will be most useful for you guys, that would be questions on this format. This format you will be asked the most. Then this theory, the factor theorem. Factor theorem would be quite useful for you. This factor theorem needs to be remembered by you guys, and the this theory of equations, whatever we discussed here. We will discuss how this theory of equations applies when it's more than a quadratic equation, cubics or nth degree. When we have one more session on algebra, like this was the pure algebra session, we'll have one more session on equations. The next part, that would be special equations, where we'll try to discuss some other things, like I might introduce some logarithms and some extra part, also some indices. But we needed the basics of quadratic equations first, so I had this session first. So today, guys, whatever has been taught, anybody, any doubt? If hopefully you guys did not have your dinner in between. Preet, whatever you missed, do have a look at the recording, and if you have any doubt, ask in the group. Is that
Yes,
okay?
yes, no
Yeah.
problem.
Anybody, any doubt then, guys? Or else we'll wrap up. Okay, I don't see any doubts then.
Kesri, geometry and coordinate geometry exercises were not sent.
Yeah, I know that. Before that, I will be giving the numbers 3. Like I said, I was waiting for the test part. That was the timing given to you so that you guys can perfect your numbers 1 and 2. You complete that test. What would have happened otherwise is I would have given you the sheets of all of them, and then you guys see the coordinate geometry and geometry part is generally like what will happen is you will also guys, one thing, do you have the previous year CAT questions with you?
Yes, we have the paper.
Okay, others?
Yes,
No
Yes,
history.
Okay, Ashwik, do you have it in PDF format?
Yes, yes, it was shared, right, for as a mock test. Everyone wrote actually. Everyone has it.
No, previous years, as not in just the 2019 part, previous years as
Oh,
in.
okay. No, I don't have the entire set. Maybe you can get it.
Okay. I'll try to share it if I like. Actually, I had the normal book. I do not have the PDF copy. Uh, it's the guys. The problem is whatever generally questions appear in your test series and the market. Generally, those are not the way how coordinate geometry or geometry is being asked by CAT. Like in some of the books, just for the namesake, they have given the questions in that way. I mean, if you even see the questions in the booklet of time and various other institutes, they have given the questions which are like not the 10 standard level. You cannot solve these questions just by using the 10 standard concepts. You need the concepts of your 11th and 12th standard, which clearly is not required for CAT, because CAT is not your knowledge intensive exam, it's your application intensive exam. So that's the reason I'm searching few more questions on that part which I can give you, because whatever questions I had made up, I've discussed it mostly in the class. So if you guys have attended that carefully and solved that questions once again, that would be more than sufficient. But I'll try to find those ones, because the thing is, CAT either asks one question from that or it doesn't. Like, it's not a hard and fast rule for CAT. CAT focuses on speed, time and distance, time and work, numbers. Then we have the initial chapters, all that were discussed, and the current ones which I'm discussing. That is why I have specifically set up such sessions on the weekend part, because even we get as normal students also, you will be relaxed on week ends compared to weekdays. That's why I place such sessions on weekends, which comparatively, I quote it again, comparatively do not carry that much weightage on CAT. That's why I have tried to fit in 2-3 sessions or 2-3 topics of quant on weekends, and the normal topics which comparatively have for major weightage in CAT on weekdays. So you will have that worksheet, you don't need to worry. It's just that to compile it and give you proper questions which will be specifically from CAT point of view, it might take time, but at least you will get this worksheet quite quickly. And numbers 3 will be shared also, because I was, like I had said, I was waiting for your test results. And I'm quite happy with the numbers 1 part. That was great. Numbers 2, I'm slightly disappointed that nobody could go above 4 questions. I mean, at least 5 or 6 could have been okay, but it's not a need to worry. We'll have one revision session in the next month for numbers as well, so that would be done. And apart from it, from whatever you guys have, if you guys have any doubts or any part in the uh, this as well, the previous worksheets as well, do post it in the group, and let's see if we can easily get it done as well. Because just do not accumulate that part, or else if it gets quite bigger, then handling those parts would be difficult. So then we'll close for the day, guys. Anybody any doubts further they wish to ask? Okay, then we'll close today.
Thank
Thank
you,
you.
Kes.